Welcome to the Lab CI/CD Big Picture. So what's this all about? So we use Ansible, which is an IT automation tool for configuring and provisioning infrastructure in the cloud to build out a bunch of servers which we will then use to house our OpenShift cluster. So what's OpenShift? OpenShift is the enterprise container platform that we use to manage application automation, deployment, and management. Once our OpenShift cluster has been created, we then create a bunch of namespaces within that project. So the first thing we do is create the default namespace, our labs dev namespace, and our labs test namespace, and then our CI/CD namespace. The dev and test namespaces, denoted by the blue boxes along the bottom, now give us a hook that we can use to allow our customers to be able to view things inside the cluster. So what else do we put into our cluster? Well, the first thing we put in is all of our CI/CD tooling into the CI/CD namespace. This includes things like GitLab, the database that's used to back it up. Once these are in, we then add in Nexus, which is the repository manager, which stores our binaries from build. Once these guys are in, we then add in a MongoDB to each of our labs dev and test namespace. And finally, we add in Jenkins. Next, we add the front-end code to Git and create our develop branch, which Jenkins is always watching. When a commit is pushed to the develop branch, Jenkins triggers a build. In order to run a build, Jenkins creates an npm build pod, a slave node where it can execute the build. The build consists of a series of steps such as source code checkout, linting, testing, packaging the application before sending it to Nexus. The next stage is called a bake, whereby the application is taken from the Nexus server, packaged into a Linux container before being stored in the internal registry. This leads to the deploy, where the application is then pushed into the labs dev namespace. The next phase is a series of tests, starting with the end-to-end tests, which use Selenium, Jenkins slave, to drive user journeys in the application. Then the Arachne web scanning occurs, and then the Zap OWASP scanning. This flow occurs on each commit to the develop branch, resulting in an application ending up in the dev namespace. However, this is usually a turbulent environment, so a test environment is needed whereby users can demo from. In order to facilitate this, we introduce a master branch, and every time a commit is made to it, an application goes through the same life cycle and ends up in the test environment. We have a similar flow then for our backend services. So starting with our product microservice, we introduce our source code into Git, create the develop branch, and then create our build job. As with the front-end code, we introduce a new Jenkins build pod, a Golang one this time, to be able to run that build. After compile and test of the code, we run a bake, same way as we did for the front end, resulting in a Linux container image of our application ready for deploy. Once our product microservice is deployed successfully, we run our Arachne and Zap scanning of the microservice to check for any security vulnerabilities. We now have a deployment pipeline which enables us to get our features into the dev namespace. By introducing a master branch to our source code, we also introduce the ability to be able to push to test. By using pipeline as code, when we introduce the new notification microservice, follows the exact same pipeline. The final thing we add in is our helper jobs for seeding the database, our build monitors, and our Grafana dashboards, as well as our Philips Hue light bulbs. All this automation and testing gives us confidence in our work and an ability to build at speed, with assurance we're not breaking existing functionality whilst delivering value. This leads us to some very happy customers.